Some of it.
Some of it. Just get some experience under your belt. I know. And then we're done, guys.
No, we're not.
Oh, then we got 2 more chapters, right?
We got a whole 2 weeks to do nothing. For me, for.
Ladies and gentlemen, can we get chapter 9 redo questions to me this week? And let's try to finish chapter 9 redo next week. Yeah, I'd like to do that. Chapter 9 was rationals. I actually wouldn't mind, maybe tomorrow we'll do some rational, like chapter 9 questions from the exam review. I think we need to simplify our understanding of it in order to do it, I won't say better, but I think if we simplify, like really boil down what we need to know about chapter 9, I think you'll feel more confident going into it. But in the meantime, let's do chapter 8.4. Holy Hannah, we are on track. I'm so proud of us. When we get back, we have 3 weeks to finish 2 chapters. It's wild. Okay, to solve a logarithmic equation, change to exponential. Again, not a very big line, but exponential form and solve. This is what Dion and I put together yesterday, and I don't know if it will be helpful for you guys in changing between forms. So we have log, and then we have the base, and then we have the argument equals the exponent, right? So that's the log form of it. And if we were to switch this in exponential form, so this is just like standard form and vertex form. They're the exact same equation, we're just changing the format of it. So then in exponential form, it's base exponent equals the argument.
Thank you, Dion.
Saving the world again, Dion. So if you're struggling with switching forms, those are not inverses of each other. Those are just different formats. Okay? An exponential, what's the difference? Like, what's chapter 7 versus chapter 8? Chapter 7, your x was your exponent. In chapter 8, your y is your exponent. So that's the difference between those two. Those are inverse functions. But these are just changing the format, like standard to vertex form from grade 11. So if that's helpful to get kind of your head around the switching of 8.1, I wasn't here for that. I'm not sure I would have added that into the notes, but if that's helpful to you, then that might, if you practice that, you'll get good at it. Once you get good at it, it's no big deal. You can do that, no problem. Okay, so we're switching it. It's in logarithmic. So we know we have a base of x. We have an exponent of 1/6, and that's equal to root 2. Okay, everybody good with that? I just switched forms. And I'm pretty comfortable with doing it, but you guys are just learning it. So if you're not comfortable with it, then keep this somewhere close and just flip back and forth. Okay, I'm going to switch this to an exponent. So that's going to be x to the 1/6 equals 2 to the 1/2. Everybody okay with that? Changing radicals to rational exponents. No one's screaming. I'm going to call it a win. We did this in another thing, but I didn't really talk about it. To eliminate fractions, multiply the fraction by the reciprocal. What's the reciprocal? What's the reciprocal to 1/6? 6. So I'm going to multiply this exponent by 6, but that means I have to multiply this exponent also by 6. So 1/6 times by 6, 1/6 multiplied by 6 is going to be just 1, right? Like that's the purpose of getting rid of it. So that would be 6 over 6, like that's 6 over 1. Multiply the fractions. And this would be 2 to the 6 over 2. So we have x to the exponent 1 equals 2 to the exponent 3. So x is equal to 8. So not hard math, but there's some tips and tricks that make this a little bit easier. And that multiplying by the reciprocal for the exponent is a big one. What are you complaining about? All right. Logs. I'm going to write this as a single log because I can't put it into exponential form until I only have one logarithm. So this is where the log laws come in. If those two things are added, what's happening to the arguments? Multiply. So writing as a single log, this will be log base 2 x times x plus 1 equals 1. So you have to get it to a single log before you change it into exponential form. You can't change 2 logs into 1 exponential form. It doesn't work. So now if I'm going to put it into exponential form.
Ms. County?
Yep.
How do you go from like log 2x plus log 2x plus 1 to just 1 log 2x?
I'm sorry, I don't understand.
Like how did we get rid of
The-
2 logs?
We applied our log law.
Oh,
Okay, so those are from yesterday. If those logs have the same base and they're added together, we can change it back to 1 log and we multiply the arguments.
okay.
Okay? So now exponential form, so base 2 exponent of 1 equals the argument. All right, so then this is another thing to remember. All right, so if x, okay, I'm trying to say it in the best possible way. Remember that you cannot take a logarithm of a negative number, because where's our asymptote? If we were to graph a basic log graph, where's our asymptote? Y equals 0, right? X equals 0. It's the y-axis. Everybody with me so far here? Yes. So how can x be negative? If there was a transformation.
Correct.
But I want you to go back and I want you to look at arguments. Okay? So this, can I take log 2 negative 2? Can I do that? Will there be an answer? Because we'd set that equal to some letter. I'm just picking that. So 2 to the exponent k would equal negative 2. Is there any exponent that would change my bases positive, negative? No, there's not. So if you have a negative argument, we have to reject it because there's no exponent that will turn my base negative. I hope that makes sense. Let it sit. Okay, I'm going to say the words again. There is no exponent that can make my argument negative. If my argument was x plus 5, could x equal negative 2? Because what's negative 2 plus 5? Is my argument negative? No, my argument is positive. Oh, this is so confusing. Okay, I promise it will get better.
Wait, check answer. You have to check.
Oh, just put the negative back into the argument. If your argument is negative,
But you don't
then you
actually have
reject
to
it.
check
No, you don't have to check it.
But then so, Ms. County.
Okay, just one sec, Rahat, and then I'm hopefully gonna answer your question with my explanation here. Okay. When I say, oh, boo, I highlighted that, not just crossed it out. When I say check all answers, what I just mean is to take your X's and put them back in for your arguments. So if I substitute a -2 in here, is my argument still negative? Yes. So I reject it. Is it negative when I put it in here? Also yes. So that's my check, just to make sure my argument is not negative. If it is, you reject it. If you have multiple arguments, like in this case, as soon as you get it negative once, you reject it. You don't have to check it in all places. So if it shows up negative once, you just go ahead and reject it. Okay, that is supposed to be highlighted. I didn't mean to cross it out. It meant to be highlighted. Okay, here we go. Property of equality. So remember how when we were in chapter 7, when we got them the same base, we could set those exponents equal to each other, and we just kind of dropped the bases. We didn't divide them out. They just went away. Same property applies to logarithms. So if these have the same base, and there's just one on either side, so a single log on either side, just like there was a single exponent on either side, we just drop those logs, and we can set the arguments equal to each other, just like we set those exponents equal to each other. So same sort of thing. So this is where your log laws come into play. We're going to apply the log law on the left-hand side because I need it to be a single log equal to a single log. Okay? So we're going to have log base 2 x minus 2 times x equals log base 2, 3. So if we have this, we have a single log on both sides. They both have the same base of 2. So now I can just drop the logs. I can just get rid of them. Because really, if you were to put this into exponential form on either side, like if we were just to look at this one separately, it would be 2 to the exponent something equals x minus 2, and this would be 2 to the exponent something equals 3. So they have the same basis. So it's the same sort of principle. We're just dropping those. So we can say x minus 2 times x equals 3. Do you guys remember when factoring was hard?
I miss those shows.
I miss those days too. Have you lost an equal sign anywhere through this?
We've been a little sore.
We all have those moments. No? All right. So, what do I need to do here before I can move on? We just got to check to see if they work in the argument. So 3, if I put 3 in here, am I going to have a positive argument? Yes. If I put 3 in here, am I going to have a positive argument? Yes. So that's good. If I put -1 in here, am I going to have a positive argument? No. So as soon as I find my first negative, I reject that answer. I don't have to check it in here. If I get a negative here, it's a no-go for the whole equation. I mean, you can check it in the next one. There's no problem with doing that, but you don't have to. All right, let's keep going.
Ms. Kelly,
Yep.
you have to be able to read the thing that we rejected.
Yes. Because I give you marks for to do your factoring correctly, and then you get a mark for rejecting the appropriate solution. So if you get in there with your pen and you completely scratch it out and I can't see it, then I don't know if you've done your factoring correctly. I don't think anybody's done that though, Rahat.
Is it possible to have X equal zero?
Yeah.
Let me check it.
Put it back in. So if x was, let's say we got x is equal to 0.
Yeah.
If I put 0 in here, would that be positive or negative? Where does 0 live? Does it live with the positives or does it live with the negatives?
That's what I'm asking.
It'd be positive. If I put 0 in here,
Negative.
would my argument be positive or negative? Negative. So we would reject that 0 because of this argument, not because of this one. 0 is always considered positive. Because we can have something. Oh no, we can't. We'd have to reject it. You're right. Because we can't have 2 to the exponent what gives you 0. Where's my asymptote? It's on 0. We can't include it.
So 0 is negative?
0 is not negative.
Weird.
It's just weird. Yeah, that's a good way to put it. Yeah, 0 we always usually include with the positive.
You add an even number to it, even if you root it, it works.
But you can't put something like 2 to the exponent what would give me 0? Nothing. We have asymptotic behavior at 0. We get really, really close to 0, but we never reach 0. Welcome to calculus. Okay, let's keep going with the next one. Log law here, so I'm going to have log base 5 2t times t minus 4 is going to put an x. And then on this side, I'm going to have log base 5 48 divided by 2. So now that I have a single log on either side, I can go ahead and drop the logs. So now you see kind of the purpose and how we use log laws and how they can benefit us with solving logarithmic equations. Some of you will go right into multiplying this. You'll put it as a single log, and then this line would be 2t squared minus 8t equals 24. And that's okay. Like, you don't need this line because some of you will do that automatically. It's not a big deal to skip that line.
Scanlon,
Yep.
what if like the first log 5 was like log 6 and the other one was log 5?
Then you can't do anything. It's like your basic grade 9 exponent rules. If they don't have the same base, you can't apply the law. Okay. What am I going to do here? Common factor of the 2. Please do not multiply the 2 by the 24. That's going to make me cry. If they're all even numbers, then just common factor of that 2, which this one happens to be. We can square things, or we can factor things way easier.
But like, if you would do common factor now, would you be incorrect?
Nope, you'd still get the correct answers.
This would be correct.
I'm just thinking if this were on a non-calculator part, I'm going to do anything I can to get smaller numbers that are easier to work with. But absolutely, if you multiplied that 2 in and did this on a 48, like factor to 48, and did the grouping factoring, you totally are going to get the correct answers because we're solving it. If we were actually just leaving it in factor form, you'd be incorrect, but or common factor at the end. Anybody lose an equal sign? No? You're all good? So now I'm going to check these in here. 6 obviously works. 6 is good. -2, Naputta good. Okay, I'm going to let you guys do that last one. Because we're not done yet. Gets a little bit more fun from here. Oh, maybe we're not gonna do this one on the same. There's no log on the other side. So can I drop my single log?
No,
So how would you tackle this question? Exponential form. So when you have to have that log on both sides in order to drop them. If you only have a single log in the equation, then go to exponential form.
Yeah. The base.
I got to here.
same and now I'm.
All. I guess that works. All. Yeah, duh, we have a number there.
So while it was in logarithmic form, I just multiplied the argument. I could have done it after, like that's not a big deal. I just did it while it was still in logarithmic form. And when I have a single log, your strategy is to change to exponential form. When you have multiple logs, you're going to get a single log on either side and then drop the logs if they're the same base. Pardon?
Well, you kept that log there, and then you moved the 3 over.
Then I changed it to exponential form.
How come you kept the log that time?
Oh, I just multiplied my arguments. That's all.
My genius.
Like I just multiplied, I did my leapfrogging.
How come you got the log on the outside?
Because I didn't do anything with the log yet, I was just multiplying the argument through. You could have totally went right to 5 cubed equals 3x plus 1,
It doesn't like disappear like the little.
because there's not a log on both sides, right? You can't, there's only a single log. There's no log on the right-hand side of that equation. These show up more than you think. These show up more than you think. Because it's like you're going along, you're solving for logs, life's good, and then all of a sudden you're shown something else where you have 1 log, not 2 logs, and then you're like, I don't know what to do. Is this factorable? Yes? What are the factors?
-24 and 16.
Negative 24, negative 16? No, positive 16.
How'd you get that?
I have, oh, you're not talking to me.
You can't do that though, because it's multiplied by 3.
I don't get this shit.
If this was x squared, it could be, it's not.
What's happening? I don't understand what's happening. Okay, you guys are over
I
there.
got a different answer from.
Pardon? What answer did
You
you?
don't have an answer yet, Dan.
8 and negative 5 and 1/3.
That's what I got,
Negative 5 and 1/3?
Yeah, I have 2 for seconds.
I think. No, I didn't. Oh. No, it's negative 16 divided by 3, yeah. Okay.
I got negative 16 divided by 3 and x equals +8.
So did we get decimals? Is that?
Well,
Negative 5.
he just converted it to a decimal.
And, which is fine, no big deal,
We
right?
looked up a decimal?
You can. You're just telling me the answer's wrong, and I think we have the same answer, just one's is a,
I got two whole numbers.
Steve did.
I'm not Steve.
What? All this time, all this time.
But how did Dion get two?
That,
What?
I got two whole numbers.
Okay, all right.
That must be.
And then you reject.
So the check here is when I put, okay, what is negative 16 divided by 3? Negative 5 1/3, negative 5.3 repeating. So if seeing that better, if that's better for your brain, when you go to check it in there, are my arguments positive or negative? And do I need to be exact? All you really need to know is whether they're positive or negative. So when I go back and I multiply negative 5.3 by 3, I'm like, that's about a negative 15, negative 15 plus 1. It's negative, I'm done, I'm walking away. If I put 8 in there, am I good? Okay. And you may get two positive answers and both of them may work, but no, you'll probably only get one answer that works, which would make sense. All right. Not terrible. Okay. All right. So this is where logarithms come into play, and you will get I guarantee you in your calculator portion, you're gonna get a question like this. You're gonna get a formula that you've probably never seen before, and you're asked to solve for an exponent. Don't freak out. Use your use your knowledge and work through it. I can't show you every possible equations. I will show you some, but if you follow these steps, you're gonna be fine. So it doesn't matter what equation they throw at you. If you know how to solve with different bases, you're gonna be okay. And if you look at our exam review, question 3. It's a log question you're gonna be asked to solve for n.
I didn't see, okay.
Right? So we're gonna be asked to solve for an exponent. No big deal. We're just gonna use our logarithm laws. We'll get there. We'll review that one maybe Monday. All right. Step 1, apply a log to both sides. And you're going to use a common log. So what's the base on that? 10. Okay. You're going to apply any log laws. What's the one log law that you see that we need to apply? That power law. We need to bring x out to the front. That's the whole power of logs, is that they take exponents and just make them things we multiply by. The reason why we do common logs, why we apply a common log to either side, just like multiplying something by 3, you got to do it to the left-hand side, to the right-hand side, it has to happen to both. With common logs, we can use our calculator. They're grounded in base 10, so we're going to stick with that. I want to isolate the x. So what's happening between the x and the log 3? What math is happening? We're really just multiplying them, right? So what's the opposite to multiplying? Divide. So if I divide this side by log 3, I got to divide this side by log 3.
Can we just murder the log numbers?
Nope. Because there's math that has to happen there.
Why no magic?
I know. We're going to use our calculators for this one, hence why it's in the calculator portion. So we're going to take log 4 and divide it by log 3.
What is a log?
Yeah,
It's a piece of
explain.
wood.
It's an
you
inverse
see that?
operation to an exponent.
That's specifically what it is.
Can you repeat that?
It's an inverse
But
operation
how
to
can
an
you just, like,
exponent.
apply logs to
Just like we can apply exponents, like we when we're doing roots, we square both sides. We have no problem squaring both sides. Now we're just logging both sides.
Is there like an equation for what a log is?
I don't know. No. It's a mathematical operation, just like a root. Like it's something that you do.
So it's an inverse of a,
An exponent, yeah.
so,
Create a formula for it, yeah.
okay. Give me 10 minutes.
Okay.
Yeah, that's questions we do ask. And then they just study from 20 minutes of the class.
All right. So it's going to get more complicated, obviously, because that's who we are as people. Or that's who I am as a math teacher. It's going to get more complicated. So again, I just used my calculator to take log 4 and divide it by log 3. All right. So we're going to do the same thing for this one, but we're going to get a scooch more complicated. Just a scooch.
Do you divide the actual logs, or do you just put it in the decimals below and then divide that?
I would do log 4 divided by log 3, and then I wouldn't evaluate log 4. Do you know what I mean? Like I would just put that in my calculator, log 4, close the brackets, divide by log 3, and get the decimal. That way I know I won't have a rounding error. Okay, what log law are we applying? Power. Okay, this is my whole exponent, so I'm using a bracket. All right. So here we go. We have to distribute backwards. And this is, so we're going to take this, we're going to multiply it into here, we're going to multiply it into here. So it would be x log 7 plus 4 log 7. Okay, pretty straightforward. Not really, it's backwards. Then we are going to bring all the x's, any term that contains an x, bring it to one side, and leave just number logs on the other. So we're going to have 3x log 2, subtract x log 7 equals 4 log 7. Okay, so maybe we need to add some more steps here.
Can you kind of increase the difficulty exponentially?
Okay, this is our next step. On the,
Can't see what you're
oh. So on the left-hand side, we're going to common factor the x out.
This is the exact order on any kind of question.
Well, this one we didn't need, like the one above it, we didn't need to, we only had x's on one side, so it was nice and straightforward. This time, bring your x's to one side, distribute backwards, oh, I forgot one.
That one's not getting ready.
So bring your x's to one side, number logs to the other, and then you're going to common factor out the x. So we're going to take out an x, so I'm left with 3 log 2 minus log 7 equals 4 log 7. And if I multiplied that x back in, it would be the same thing. So this is just algebra. Like, this isn't ugly algebra, but it really is just algebra. It just looks really difficult. I want to isolate the x. These two things are multiplied. So I'm going to divide this whole side by 3 log 2.
I'll leave this over.
Okay, I want you guys to try that in your calculator, and you're going to need to use brackets.
So would you only have questions like this on a calculator part?
Yeah, yes, this would be solidly in the calculator part. You guys can expect to have one of these questions for sure, like this level, on your test and on your quiz. This will be on your test and on your quiz. It probably, one straightforward like this won't show up on your, no, it was there. It was a question that I wanted to do today. And then I said, we'll do it tomorrow. Yeah, you're gonna do them on the exam, the test, the quiz. It's a good time. Okay, so 58.2907.
1684.
So did you get that in your calculator? If you didn't, did you use brackets appropriately? Because if you didn't put the denominator in brackets, it would have done this division and then subtracted log 7 off of it.
58.2907.
Okay? And we're going to get more complicated from here as well. Okay, so let's apply logs to both sides. What am I going to do with that left-hand side? What? Going to turn it into a plus? And I'm going to apply a power law to the second one. No, you were right. That was the new, sorry. So I did the addition law, like the arguments being multiplied. So I did the addition and I did the power all at once. I don't know how you guys feel about that. So I got to distribute backwards. Okay, what's my next step? All the logs with variables I like to do it to the left-hand side, doesn't really matter. They just have to all be on one side. And then just the logs with numbers on them go to the other side. So I'm going to have x log 3 minus x log 5 equals log 5 minus log 2. What's the next step?
Common factor of the x.
Common factor of the x. And then we are going to isolate the x by dividing out what it's being multiplied by. Okay, now I know a lot of you are going to say, there's a log 5 on both top and bottom, and I'm going to lose my mind. You cannot just cancel those out and give it as a 1. Like, it's a fatal flaw. Don't do it. Just put this in your calculator. Numerator should be in brackets. Denominator should be in brackets.
What has to be in brackets, both?
Both. Natural logs is a really good one.
Can you get a negative?
Yep. Can you have negative exponents? Because where are your x's in this? They're in your exponents. So is it okay to have x as a negative answer here? Yes, because it was an exponent, so x being negative. What is the answer? Negative 1.7937. All right, we are going to at least get through one of these word problems. We're going to get through at least one. Okay. Rahat, there's nothing on Instagram that's more fun than what we're doing right now.
Wow.
Wow.
That's on his Instagram.
Wow, not
I-
dude.
Whoa. Whoa.
Yeah.
Okay, I'm a little traumatized. Can we just stop?
That's crazy.
Okay. Future generations will get to listen to this lesson, and they'll hear stories about Rahat's Instagram reels. I can't wait until the future classes get to hear about this. Okay, let's do the second example first. The rate at which an organism duplicates is called its doubling period, and given by this equation, where n is the number present after time t, and the n initial is the original number of organisms that we started with, and d is the doubling period. E. coli is a fun bacteria that nobody wants, can cause food poisoning, sometimes death. That's never fun. Suppose biologists originally estimates that the number of E. coli bacteria in a culture is 1,000. After 90 minutes, the estimated count is 19,500. What is the doubling period for E. coli to the nearest minute? Woo, that was a lot of stuff. T is measured in, I'm going to say minutes. I didn't say that in this, but I'm going to say that it's minutes. So let's fill in what we know. We know that the final amount is 19,500. What was the initial amount of E. coli bacteria? 1,000. It's doubling. That's exciting. How much time has passed? 90 minutes.